Hey everyone, welcome to another live coding. Hope everyone has had a good week so far. So, in today's live coding, we're going to look at bodies of water and segmenting them. So we're looking at satellite images and seeing, trying to find where in these images these bodies of waters are. And hopefully by that we can hopefully use it for some cool things, such as seeing if there's flood somewhere or if a dam has broken or something like that. But let's jump straight into it by looking at what kind of data we're going to use as normal. So the data set we'll be using is looking just like this. We have our images and we have our masks. Nothing too different from normal segmentation. And yeah, we can take a look at a few of these images. We'll see that many of them are in very different shapes. So we'll need to do some reshaping on them to make sure that they will fit inside the tool and we'll be able to go through the unit or the model in general. We can also see that a few of them looks to have been rotated already, or something a little bit strange is going on with these ones, for example. So we can probably try without any pre-processing, as yeah, these look very much to already have been pre-processed. Then we'll have the masks, and the mask simply highlights where in the image this water will be, which look pretty cool actually. They look kind of like neural networks, or just what are they called? Sensory, well, neurons. Let's go with neurons. And we can see in some that we have no water at all, or actually full water. And I'm sure we have a few with no water at all, or little water as well. So this we'll be using to know where in the images the water actually is, and to start teaching the model to segment it. And the CSV file looks like usual. We'll pop it up real quick just to show. But it's essentially going to take images as inputs and masks as targets. Nothing surprising there. We just divide it into two different columns. All right, so let's jump into the tool. So have it, there we go. So I'm gonna go ahead and create a model as usual. I already have the data sets loaded here, ready to go. And the images, as we said, should go as inputs. Masks we'll put as targets. And we need to do a little bit of pre-processing. One thing I didn't mention was that the masks are just binary masks. So they only have two classes, a background class and a water class inside them. We'll soon be adding a multi-class as well, so you can have multiple classes that you segment. For example, if you want to segment dogs from cats from humans, you'll be able to do that with a multi-class mask. But for this one, just normal binary works fine. And what we want to do in these images and the masks is that we want to normalize them. And the big reason why we want to normalize the masks, we want to normalize just to make sure that it's binary. We have zeros as the background, and we have ones as the objects, water in this case. The images we want to normalize still, because because it's very easy for a unit to not train that well. And what I mean with that, and we're going to see it as well, in many cases, the unit starts training a bit, you see the gradients changing, and then he has die, which is not optimal when you want to train a model. So one way to prevent that, or to help that a little bit, is to make sure that the input is normalized. You're not going to get any values you don't expect, or there is no outlying values in the inputs. Everything is neat and tidily between 0 and 1, as it does with min-maxing. So that can help a lot. The second thing we want to do is resizing. And we're going to use 224 by 224 because that's what we need for some of the pre-trained models. We'll see if we do use a pre-trained model here, try it out with it, but just in case. We'll do the same on the masks. Then we can start creating the model. All right, so we now have the inputs and the targets, and all we're gonna do is throw in our unit component. We're not gonna build it by hand. And we already see how the unit component is white as the output, meaning that pretty much regardless anything we put in, we're just gonna get white out. And the reason that is because we have softmax here. And softmax essentially just caps everything between 0 and 1 on the output. And if you have larger than 1, it's gonna cap it to 1, and things are not gonna go very well. So we'll move this one to sigmoid. Another thing I noticed works really well for units is the batch normalization. And what batch normalization does is before or for specific layers, for the layers where batch normalization is enabled, it will normalize the input to that layer for the entire batch or mini batch. And what's good with that is that you have a stable input. Nothing is going to go outside expected values, and that can really help stabilize the training, which very often is needed with units. They're a bit fickle to train at times. And I think we can start just with that. That's as vanilla as we get it. We can also take a quick look in the code and we'll see we have 4 levels. And that can work fairly well. So we'll try that, and then we can try adding on some more layers, or we play around a bit with the different backbones. Let's get running it. We'll do 1 epoch, batch size 32. In the latest update, the dice and Kira's dice are merged into just a single dice. But if you do have the version where it says dice or Kira's dice, make sure to select Kira's dice. And then we just run it. And we'll just wait for it to start loading, or start running rather. It took a bit of a larger batch size, so it might take a while just because of that. Still not starting. Alright, let's try running it with a smaller batch size then and see if that works better. Let's go with just 4. Actually, let me do one thing in the background real quick first. As we see things aren't quite loading, I'll just try a quick restart on the kernel. Alright, let's try with this. Well, hopefully at least. Okay, you're loading. Let's try running it. Okay, so smaller batch size. See if this one works a bit better. There we go. Okay, cool. Alright, so first thing first, now that it's running, let's take a quick look at the gradients, and we can do a run after this as well, where we don't have batch normalization, just to compare how it looks like without it, and see exactly why the unit is a little bit tricky to train at times. I also only choose one epoch for this one because it is quite a large amount of images. I think we have 1,300, which is awesome. It makes it a lot more variety to train on, but it takes a bit longer. So I figured we would start the training, see how well it goes, and then try a new model and kind of compare how the different starting conditions of them look like, and talk a little bit about what may or may not work in general for units. The loss is not saying very much. One more interesting thing to look at is we can always look at the what we're actually outputting, and or rather we have the output there, so we'll look at how the target looks like, and we can compare slightly the prediction with the target to see that it actually looks pretty good at times. It's missing a few things here and there. I found that attention nets, or attention units rather, are quite good at helping with those small missing pieces. So that's something which could be tried as well. But another thing would be to increase the size of the unit, or play around a bit with that and see if that helps. Larger size unit adds larger complexity, which adds more capability for nonlinearity and for more complex surfaces, is what it boils down to. Alright, I think we could let this one finish training. It looks like it's gonna be, I mean, it's already predicting decently on some of them, but from experience, the validation's not gonna look amazing for the first epoch. So we can stop this one for now and go back and try another iteration of the model and see how that works. Okay, so standard with batch norm works really well. Let's do a quick without batch norm, just to showcase what happens if you don't do it. And in some cases it works just fine, but in some cases it really doesn't. And again, looking at the preview of the unit, you just see a white screen, or a white, not screen, a white output, which hints that it doesn't have any variety in it, which is going to make it so much more difficult for it to learn. So let's see if this one picks it up. Yeah. This is why Unit is sometimes painful to train. Without it, you can see we have gradients a little bit to the start, and then they just die. And at this point, the unit is only predicting once everywhere. We do still have an IOU, because we do have some overlap. IOU stands for intersection of union, meaning how much does our prediction overlap with the target. But since it's predicting essentially all white, it means that it doesn't really connect this prediction to the target anywhere, or to how it should look like, so the gradients just die at that point. So we can stop this one and go back to our batch normalization. There we go. And then try throwing a backbone on there, which I don't think we did last time. And so backbones are pretty great in many cases. They, especially if you use that it has weights already, so it's already pre-trained. And it can help with just speeding up the training a lot, getting you to higher accuracy faster, thanks to the fact it already has trained, it already has good weights for a bunch of scenarios. We showcased a lot with pre-trained models for image classification, but the principle is the same for segmentation in units. It's just a unit with pre-trained is a bit trickier to build by yourself than it is for classification, just because the nature of how a unit looks like. Alright, so I'm just keeping a close eye on the gradients for the first few iterations to see that they don't completely die off instantly. But as soon as it's gone a little bit and we're feeling fairly secure that it'll continue training without dying, we can swap over to look at the targets. And to be fair, this is a little bit more eye candy, since we're not seeing every single image this way. We are seeing some samples of predicted versus targets. But it still gives you a good sense if it's heading in the right direction, especially when you couple it with the IOU. And it can help figure out where the model is kind of missing. Of course, we have the test for that as well, where if you run the test, you'll get a bunch of visualizations, both of the best ones and of the worst ones, and that can guide you quite a lot. But This is also nice for real-time evaluation as it's training. You can also take a look at the input and see how well our prediction overlaps with the inputs. So in some cases it's decent. We'll at some point also add GradCam into the tool and saliency maps. It's something we had on our radar for a long time, but haven't quite gotten in yet. But what they would do is it's actually pretty decent at the moment. Anyway, what saliency mapping or GradCam would do is that you could see in the images where it has the most focus. For segmentation and for units, that's essentially what it is if you have a heat map of the predicted image. So that's something we'll get in as well. But for normal classification, you can see where in the image it draws the classification from, where it takes its conclusion from. And that can be really helpful. Say that you are classifying a bunch of images and all the images have a timestamp on them. And it doesn't really seem to care when you're generating the images or when you're picking the images because it's just a timestamp. It's going to ignore it, right? But then you realize that you're also trying to predict, let's say, whether or not the sun is up. Silly example, but what the model can start doing then is, instead of looking at this image and look at is it bright or is it dark or do I see a sun, you'll just look at the timestamp. And if you have a saliency map or a GradCam, you can very easily spot if that happens, because on all your test images, you'll see that the model only focuses in the top right corner or wherever you put the timestamp, and nowhere else. And the predicted image for segmentation is somewhat similar if you do it as a heat map, because then you can see where it focuses the most. And for example, some of these, if you get some of these outer parts, you see them a little bit grayish, which would mean the model is not as sure on those parts. And if you use a cutoff, so after you do your prediction, you're obviously going to get values between 0 and 1 for every single pixel. And if you do a cutoff on 0.7 instead of 0.5, for example, it can help remove a lot of these uncertainties and this random noise you may see here and there in images. Yeah, but as you can see, the unit is taking quite a bit longer to train than a normal classification model, and this is just one epoch as well. Well, admittedly, it is doing really well for just one epoch so far, so that's good. But since we're not gonna be able to finish this one in just the 5 minutes we are left of the of this live stream, I'm probably gonna do a instant model of this, either of this one or a very similar one, where I train it to good performance, or at least completion, and then show how that would look like And especially interesting then would be to look at the test and see how well the predictions looked like on the test data. Just taking a quick look at the gradients here, making sure they're still alive and we're still learning. You can see that the IOU surely but safely is going upwards, so that's good. But we only have a single point so far. Yeah, we can stop this model here. It looks like it was anyway loading for something. So, but even after 33%, it performed pretty decently. At least on the training data, we will have to see on the validation and testing data, of course, before making any judgment on it. And a real judgment, at least. And while I have you all here, if you don't already, make sure to join our forum as well. We're having more and more fun conversations there, and we're also looking to get serving or being able to run the model inside the tool, so you don't have to export it and run it outside the tool. And if you want to give feedback to that, just head over to the forum and take a look at what we're looking to do. And much more cool things upcoming there. But besides that, thank you all very much for joining. Always a pleasure having everyone here. And have a great day and a great weekend. Take care, everyone.